From the primordial cloud of gas and cosmic dust, gravity forged the stars as monuments of the balance between the mighty power of attraction pushing in and the nuclear interaction pushing out. The stars are the most widespread objects in the universe. These enormous balls of plasma are the main source of light and energy in the cosmos. Our Sun is the power needed to support the development of life on Earth. In the field of stars, the evolution led to the creation of extraordinary wonders. The life of each star begins in so-called stellar nurseries, vast interstellar clouds. Gravity gathers gas and cosmic dust into a single object. The mass of that object is so tremendous that the elements begin to fuse and the star lights up. The nuclear fusion releases huge amount of energy that pushes outwards and thus stabilizing the star. Different stars have different properties, for example, different mass or fusion of different elements. By these characteristics, the stars could be compared. Stellar classes are determined according to the Hertzsprung-Russell chart that expresses the dependence between the luminosity, which depends mainly on the mass or radius of the star, and its spectral class, which depends on the temperature. At first glance at the diagram, we can notice the accumulation of stars in a certain sequence that the scientists call main sequence. We can see that the hotter the star is, the more massive it is. On the left are the blue supergiants, which temperature could reach over 28,000 Kelvin. For example, Orion's Mintaka, with temperature exceeding 29,000 Kelvin. In the other end, there are the cold red dwarfs. Our Sun is somewhere in the middle of the sequence, at 5,780 Kelvin. Throughout the development of the stars, they can move across the diagram. The Sun will slowly begin to run out of fuel. Throughout its life, the Sun had fused lighter elements into heavier ones. The new forged elements release more energy, making the star wider. However, their kinetic energy is less, which cools down the star. This moves the star upwards to the right in the diagram. Then, as the Sun's core begins to fuse silicon into iron, the fusion will no longer be able to stop the gravitational inward push, and the Sun will become a white dwarf, extremely hot and dense star, the end and the new beginning of the solar system.